DC characteristics of op-amp. Then we can see the DC performance characteristics of op-amp. Some of the DC performance characteristics of op-amp are input bias current, input offset current, input offset voltage and thermal drift. Input bias current, input offset current, input offset voltage and thermal drift. Here now we can see the input bias current. Okay, here in the input bias current, let us take the op-amp. This is op-amp, so this is the diagram of the op-amp, and here in this op-amp we are giving, we know that we have two inputs, that is inverting terminal and also the non-inverting terminal. In the inverting terminal we are just giving, that is we are just giving the input, that is current to this inverting terminal is given as IB minus, and the current to this non-inverting terminal is given as IB plus. Okay, and here it gives the output as V0 maybe the is the output of this particular op-amp. Okay, here input bias current means what is going on this input bias current. Here we are, if you are not giving, actually if you are not giving the input, no, if you are not giving any input to this input op-amp means the output must also be 0, but in practical cases it is not possible. Okay, there may be, that is if you are not giving the input, there may be some output present in the output of this particular op-amp, and the output may be in the form of nanoamps. Okay, this is known as the bias current. Here if you are using either identical transistor, we are just giving IB minus and IB plus must not be exactly same. IB minus and IB plus must not be exactly same. That is that because there may be during manufacturing the two inputs are not same, so IB plus and IB minus are not equal in practical. Okay, IB plus and IB minus are not equal in practical cases. Therefore, the two currents that is given to this two inverting terminal and non-inverting terminals are not equal. Here, the average value of these two currents flowing into the op-amp input terminals is called the input bias current, that is IB. Okay, therefore, IB is given by the equation IB plus IB minus by 2. That is, we are just taking the average of this two current. Okay, since the two input currents are identical due to the mismatch of in transistor, the two input current is identical due to the mismatch in transistor. Therefore, we are just taking the input bias current is calculated by taking the average between the two current flowing to this two input of this particular op-amp terminal. Okay, and also IB1, that is IB plus or IB1, it is the current flowing to the non-inverting terminal, and IB2 or IB minus is the current flowing to the inverting terminal. Okay, and then the input bias current is given by IB equal to IB plus IB minus by 2. Now the second characteristics is input offset current. In the second characteristics is input offset current. Input offset current is, that is the, here in this case the bias current compensation will work if both bias currents IB plus and IB minus are equal. If there is the IB, if both IB plus and IB minus are equal, then only the bias current compensation will work. Okay, since the input transistor cannot be made identical, the two terminals of this input transistors are not identical due to the manufacturing fault, therefore there will always be some small difference between this IB plus and IB minus, and this difference is said to be the input offset current, and this difference is said to be the input offset current. Okay, and it is given by IOS equal to IB plus minus IB minus. Okay, this is about the input offset current. Okay, and the next one is input offset voltage. Okay, here in this input offset voltage, it is found that the output voltage may still not be 0 with input that is, if you are giving the input as the input is 0, the output must not be 0. That we have already studied that due to some practical defect, that is due to the in practical, if the input is non-zero means due to the biasing current in that particular op-amp, there may be some current produces into the output. Okay, this is due to the unavoidable imbalances inside the op-amp. This is due to the unavoidable imbalances in the op-amp. To avoid this, we are just giving a small voltage as the input terminal to make the output to 0. Okay, actually in practical cases, that is, if the input is 0, the output must also be 0, but in this, due to some circuit imbalance, there may be some output produces as the output produces even though when we are giving the input as 0. Okay, to avoid that, we are just giving the small voltage to this input to a terminal to make the output to 0. Okay, this voltage is called the input offset voltage, that is said to be VOS, and this is the voltage required to be applied at the input for making output voltage to 0. This is the voltage that is applied to the input terminal to make the output voltage to be 0. And next one is output offset voltage. Here the output offset voltage, here in this output offset voltage, the effect of the input bias current, offset current and the voltage is to be added to add the error to the DC level of the output. To this produces the output voltage when both the input is grounded. Due to the effect of this input bias current, offset current and voltage is to be added, there may be some output at this DC level at the output, and this produces the output voltage when both the input is grounded. Thus the DC voltage present at the input at the output when both the input is grounded is called the output offset voltage, that is said to be VOS. Okay, and the last one is thermal drift. A thermal drift means that is the bias current, offset current and offset voltage changes with temperature. Due to this, there may some drift in the current occurs, and also in the circuit when we are carefully nullified by 25 degrees Celsius, they may not remain. Okay, the circuit carefully nulled by 25 degrees Celsius may not remain. So when the temperature rises to 35 degrees Celsius, this is called the drift. Okay, this is called the drift, and the offset current drift is expressed as nanoampere per degree Celsius. Okay, and this indicates the change in offset of each degree Celsius changes in temperature. Therefore, some of the DC performance characteristics are input. Some of the DC performance characteristics are input bias current, input offset current, input offset voltage and the thermal drift. That's all. Thank you.